This is a video walkthrough of the Unit 3 review, Part 2, which is the calculator portion. In 14, we're asked to write a system of equations as an augmented matrix. Before doing so, we have to make sure that all of our equations are in standard form. So, the first two equations look to be in standard form. 3x plus 1y plus 1z is equal to 5. And 2x minus y plus z is equal to 6. This equation needs to be written in standard form, and so it has no x's in the equation, plus a y, and then we're going to move the 2z to the left side of the equation, so minus 2z equals 2 on the right side of the equation. We can write that in augmented matrix form. 3, 1, 1, vertical line, 5, and then second row, 2, negative 1, 1, 6, and third row, 0, 1, negative 2, 2, and then we can have the calculator place that in reduced row echelon form. So let's grab the calculator and input that command. We have to tell the calculator what to do. RREF, oops, we need the home screen there. And then calculate, so we need a calculator scratch pad or a document. RREF, open parentheses, and then menu to the right of the 9, and we're entering a 3 by 4 matrix. And then enter the elements on each row. And especially when you're doing this, it's a lot of elements. So when you're done entering them, take time to look at them and look for any errors. Check each element, and I just found one that I had misentered. And just check each row. And now it looks like I've got them in place. And the resulting matrix has a right side of 3, negative 2, negative 2. And then the identity matrix on the left side. And that means that our ordered triple solution is 3, negative 2, negative 2. For 15 through 19, we're to define variables and write a system of equations to represent each situation and then solve the system using the calculator. We're going to write down that system before solving. So make sure that we're not just grading what's in your calculator, right? We're grading what's on the paper. All right, so this is a mixture problem. A prescription calls for 60 milliliters of a solution containing 30% medication. A 25% and a 40% solution are available to mix together. How many milliliters of each should be used? So pretty standard for a mixture problem. A percent times the amount of the solution equals the medication content, how much medication is actually in the solution, or a percent of each solution is medication, if you want to think of that in terms of a word key. All right, where our two pieces that we are mixing together are a 30% medication. I'm sorry, that is what we're aiming for, right? The available solutions are a 25% and a 40% solution, and we're going to mix them together. And I don't know how much of each. 25% of X is the amount of the medication in the first solution. 40% of Y is the amount of medication in the second solution. And then, of course, we have a third row for a mixture problem. So in the third row, our mixture is supposed to be a 30% medication, and we are looking for 60 milliliters of that solution. 30% of 60 is 18. All right, if you think about 10%, that's an easy computation to make. Or we can just multiply, of course, on our calculator, 0.3 times 60. Of course, that is in computations you should be able to do on your own. All right, so from here, our amount of solution totals and our amount of medication totals. those will be our two equations for the system. X plus y is equal to 60, and 0.25 times x plus 0.40 times y is equal to 18. Let's write that as in an augmented matrix, 1, 1, 60, and 0.25, 0.40, 18. Don't forget that vertical line. And then we're going to write this in reduced row echelon form. So the system leads to an augmented matrix which goes in reduced row echelon form. All right, I'm going to enter this into the calculator. Don't forget to type RREF, open parentheses, and the menu key to the right of the 9. And this is a 2 by 3 matrix. And across the top, 1, 1, 60, 0.25, 0.4, 18 across the bottom, and that gives us 40 and 20. And so we have 40 is the value of x, so 40 milliliters of the 25% solution and 20 milliliters of the 40% solution is what we should mix together. Number 16 is a tailwind and headwind problem. So in these we have our rates, which are measured in miles per hour, and then that multiplied by the number of hours gives us the miles traveled. And in this particular situation, a helicopter traveled 300 miles in 1 hour and 40 minutes, and then the return trip against the same wind took 20 minutes longer. So we have a tailwind first, and that trip was 300 miles, and 1 hour and 40 minutes is 1 2/3 hours, which as an improper fraction is 5/3 of an hour. And with a tailwind, the rate of the helicopter gets the wind speed added to it, and then the return trip is with a headwind, and of course our rate there is the rate of the helicopter minus the speed of the wind, and so that took 20 minutes longer returning. So 1 hour and 40 minutes plus an additional 20 minutes is 2 hours, and the return trip is the same distance, so 300. And now we can just take our rate times our time and set that equal to the distance traveled, so for each trip. So 5/3 times r plus 5/3 times w is equal to 300 is one equation, and then a second equation is 2 times r minus 2 times w is equal to 300. Let's write that in augmented matrix form. 5/3, 5/3, 200, and 2, negative 2, 300. And then we can let the calculator put that in reduced row echelon form for us. So type the letters RREF, open parentheses, menu key to the right of the 9, and we're creating a 2 by 3 matrix. 5/3 is the first element. 5/3 is also the second element, and 200 completes the first row. In the bottom row, 2, negative 2, and 300. And in reduced row echelon form, that gives us something that does not compute, because you notice that one of our results here is negative. And as I look at what I entered, I notice that I mistyped an element in the matrix. We're not expecting negative answers here, so I'm going to redo that calculation and insert the correct element there. And now we get 165 and 15. So here's our equation in reduced row echelon form. It's important to notice that the first element there, where we have a 1, is the r column. So this is the value of r. So r is the speed of the helicopter. So the helicopter speed is 165 miles per hour, and the wind speed is 15 miles per hour. In 17, we have a candy store that needs a special mixture of candy. So hint, this is a mixture problem. Cream-filled chocolates that sell for $3 per pound. That sounds like a rate, dollars per pound. Okay, so we're going to set up our table here with a rate measured in dollars per pound. And if we multiply dollars per pound by the number of pounds, then we should get a dollar value for each of these candies here. So we're going to mix them together, and let's see what we are mixing. We have cream-filled chocolates. I'm just going to write that abbreviated as cream. And the information on those is that we have those measuring $3 per pound. And we don't know how much we should use of each of those. So their dollar value is 3 times X. And then we have the chocolate-covered nuts. So our chocolate-covered nuts sell for $2.70 a pound. And we don't know how much we should use of those, but their value would be 2.7 times Y. And then we also have our raisins here. And the raisins sell for $2.25 a pound. And we don't know how much of those we should use, so I'll call that amount Z. And their value would be $2.25 times Z. And then we have the mixture here that we're trying to create. And our mixture, we're looking for it to be $2.80 a pound, so $2.8. And we're looking to make 45 pounds of it. So we can do a multiplication now. 2.8 times 48. I'm sorry, 2.8 times 45, and that is $126. So we want the whole thing to be worth $126. So now let's write our equations. We have one, the total number of pounds, x plus y plus z is equal to 45. And then we also have the total value, 3x plus 2.7y plus 2.25z is equal to $126. And then we have this one more piece of information that we need because, of course, we have 3 variables and we need 3 equations if we're going to solve this system. So here's a sentence that tells us that she wants to have twice as many raisins as nuts in the picture, in the mixture. So if there are twice as many raisins as nuts, that means that the number of raisins is equal to 2 times the number of pounds of nuts. So if there are twice as many raisins is going to be bigger. We take the smaller number and multiply it by 2. Now let's take that and move that into standard form. Oh, and of course I've written R and N for those, but our raisins are actually Z. The number of pounds of raisins is Z. I'm getting that from looking at my table. And the number of nuts would be Y. So Z is equal to 2 times Y. And if we rewrite that in standard form, that will be 0x plus 2y minus z is equal to 0. Now we can take and rewrite this as an augmented matrix. 1, 1, 1, 45 across the top. 3, 2.7, 2.25, 126 for the middle row, 0, 2, negative 1, 0 for the bottom row. And let's get our calculator to give us the reduced row echelon form for that. And so I'll type the letters RREF, open parentheses, and the menu key to the right of the 9. This is a 3 by 4 matrix. Across the top, 1, 1, 1, and 45. Middle row, 3, 2.7, 2.25, 126, and bottom row 0, 2, -1, 0. And I probably typed something incorrectly here. I did. And I got a weird answer, so I'm going to look at what I may have mistyped. I didn't take the time to check every element in the matrix, and I think I just found my mistype, and that looks much better. We get 35 and 10. And 30 is the number of pounds of cream filled, and 5 is the number of pounds of the nuts, and 10 is the number of pounds of the raisins. And there's the answer to that question. In number 18, we have a geometry problem. Yay! The largest angle in a triangle is 26 less than twice the smallest angle. So I'm going to draw my triangle, and I'm drawing it in such a way that we can see where the largest and smallest angles are. This looks like the largest angle. That one looks like the smallest angle. So the largest angle is 26 less than twice the smallest angle. So let's let the smallest angle be x. The largest is 26 less than twice that. And the middle angle is 40 more than the difference between the other two angles. Find the measure of the largest angle. Now, this is one way to do the problem. And of course, now it occurs to me that we are supposed to come up with many different variables here. So what we're going to do instead is we're going to make our smallest angle x, our medium angle y, and our largest angle z. And then we're going to write some equations that involve 3 different variables here. So the large angle z is 26 less than twice the smallest angle, so that would be 2x minus 26. And then the middle angle, y, is 40 more than the difference between the other two angles. So the difference between the other two angles would be z minus x, the bigger minus the smaller, but 40 more than that, so add 40 to that. And then we're going to find the measure of the largest angle. So you notice that we have 3 variables and we only have 2 equations so far. There's one more equation, and it's the one you should always be looking for. The 3 angles of the triangle add up to 180. Now all of these have to be moved into standard form. So my first equation, if I move my z to the other side of that equation, so I'm going to move the z over there, and I'm going to move my 26 over there. So that's going to be 2x minus plus 0y minus 1z is equal to positive 26. Of course, if you move things to different sides, you may have the opposite of all of those coefficients. And then similarly for the second equation, we can move our y over there and our 40 over there. And in doing so, in standard form, this is negative x minus y plus z is equal to negative 40. And again, you move things to opposite sides, you can have opposites there. And then the last equation, x plus y plus z is equal to 180. Now we're going to write this in reduced row echelon form. But before doing so, we're going to write the augmented form of the original augmented matrix form of the original system of equations. Your equations can be in different orders. They can be multiplied by -1 for sure. Okay, and we're going to get equivalent results. All right, so let's enter that in to the calculator. We want reduced row echelon form of a matrix. And that matrix is 3 by 4. And across the top, 2, 0, -1, and 26. Middle row, -1, -1, 1, and -40. And bottom row 1, 1, 1, 180. And we get 48, 62, and 70. So x is 48, y is 62, and z is 70 is my solution. All right, in 19, we have a quadrilateral, and please remember that the sum of the angles in a quadrilateral is 360. So one equation that we can write is x plus y plus z plus 72 is equal to 360. We're going to want to put that in standard form. X plus y plus z is equal to, and then subtract 72 off, and that would be 288. So there's one of our three equations. And then a second equation can be written by identifying a linear pair of angles that add up to 180. So x plus z plus 15 is equal to 180. So in standard form, that's 1x, or just plain old x, plus 0y's plus 1z is equal to 165. We have to subtract that 15 from both sides so that we have that standard form. And now we need a third equation, and our third equation comes from the second linear pair of angles. So for that linear pair of angles, y plus z minus 13 is equal to 180. Putting this in standard form, 0x plus y plus z is equal to 193. Let's write that in augmented matrix form. So top row from the first equation, 1, 1, 1, 180. Second row from the second equation, 1, 0, 1, 165. And third row, 0, 1, 1, 193. And then we can solve that using the calculator. And I'm going to input a matrix that is 3 by 4. And across the top, 1, 1, 1, 180. And middle row, 1, 0, 1, 165. And across the bottom row, 0, 1, 1, 193. And I'm getting some answers that I don't quite believe there. I'm just going to check to see if I have mistyped anything. And of course I did mistype something, so I'm going to go back and correct it. My top row should not have a 180 in it. That number in the top row should be 288. I'm going to correct it both on my paper and in the calculator. So just go back and check to make sure that you've copied everything correctly from step to step. It's a really easy mistake to make. And so our x value is 95, y is 123, and z is 70. So x is 95, y is 123, and z is, I think it was 70. And that's a wrap. I believe that's the last problem on the review.